Hello guys, welcome back to the channel. So now we are continuing with exercise 1.2 of real numbers. Okay, so let's see the first question. What's the first question? Express each number as product of its prime factors. We have to express these numbers as the product of its prime factors. So the first one is 140. Okay, so 140, we have to do the prime factorization of 140. So how we can do that? 140, which is the smallest prime number which we can use here, that is 2. Since it is ending with 0, since it's an even number, we can use 2. So it's 7 2s are 14, 70. Again, it's an even number, we can use 2. So what we will get? 35. Since it is ending with 5, we can use 5 here. 5 7s are 35. 7 1. So how we can write? 140 is equal to 2 into 2 into 5 into 7. Also we can write 140 is equal to 2 square into 5 into 7. So this is our solution. Now let's see the second one. Second one is 156. 156. Since it's an even number, we can use the first prime number as 2. So 7 2s are 14, remaining 1 16. 8 2s are 16. Again, it's an even number, we can use 2. 3 2s are 6. 9 2s are 18. 39. Since it's not an even number, so we cannot use 2. So which number we can use? The next prime number, it can be 3, because 3 and 9 both are divisible by 3. So 3. 1 3. Anything more we can do? 13. Since 13 is a prime number, that's all. So we can write 156 is equal to 2 into 2 into 3 into 13. So we can write 156 is equal to 2 square into 3 into 13. So this is our solution. Okay, let's see the next question. That is 3825. Okay, it's not an even number, so we cannot use 2. Since it is ending with 5, straight away we can use 5. So 5 7s are 35, remaining 3 32. 6 5s are 30, remaining to 25 5. Again we can use 5 since it is ending with 5, remaining 2 26. 5 5s are 25, remaining 1 3 5s are 15. Okay, now what we can do? Which number we can use here? 153. 2 is not possible, since this is an odd number. 2 is not possible. Next number is 3. How we will get to know that if it is divisible by 3 or not? We will add all the digits of this number, and if the sum of these digits are divisible by 3, then the whole number is divisible by 3. So 5 plus 1 is 6, 6 plus 3 is 9. 9 is divisible by 3. That means 153 is also divisible by 3. So we will put 3 here. 5 3s are 15. 1 3 3. Okay. Again, is this divisible by 3? 5 plus 1 is 6. 6 is divisible by 3. So 51 is also divisible by 3. 3. 1 into 3, remaining 2, 21. 7 into 3 is 21. Since 7 is a prime number, 1 into 17 is, 17 is a prime number, 1 into 17 is 17. So we can write 3825 is equal to 5 into 5 into 3 into 3 into 17. That means 3825 is equal to 5 square into 3 square into 17. Okay, now let's see question number 3. 5005. We have to do the prime factorization of 5005. 5005. Since it is ending with 5, we can use 5 as the first prime factor. So 1001. Can we use 2 here? No. This is an odd number. So we cannot use 2. Can we use 3? 1 plus 1, 2. 2 is not divisible by 3. So 3 is also not possible. Next prime number is 5. 5 is also not possible here since it is not ending with 0 or 5. Which is the next prime number, that is 7. Will 7 divisible 1001 is divisible by 7? We will see. 1 into 7 is 7, the remaining 30. 4 into 7 is 28, remaining 1 21. In 21 7 is divisible. Okay, so 7 is divisible. In 10 1, remaining 3. In 30 4 7s are 28, remaining 2. In 21 3 7s are 21. Okay, next 143. 2 is not possible since this is a odd number. 3 is 3 possible. 4 plus 1 5. 5 plus 3 is 8. 8 is not divisible by 3. So 143 is also not divisible by 3. So which is the next number? 5 is also not possible. 7. 2 into 7 is 14, remaining 3. So 7 is also not possible. Next one is 11. 1 into 11 is 11, remaining 3 33. 3 11s are 33. So 11 is the next prime number we can use. So 1 into 11 is 11, remaining is 3 in 33. 3 into 11 is 33. So we can write 5005 is equal to 5 into 7 into 11 into 13. So this is our solution. Okay, now let's see the next question. 7429. We have to do the prime factorization of 7429. Can we use 2? No. Since this is an odd number, we cannot use 2. How about 3? 7 plus 4 is 11. 11 plus 2 is 13. 13 plus 9 is 22. 22 is not divisible by 3. So this number is also not divisible by 3. Next prime number is 5. 5 is not possible since this is not ending with 0 or 5. Next one is 7. We will try with 7. 1, 7 in 42. 5 7s are 35. No. 6 7s are 42. Remaining 9. So 7 is also not possible. Next one is 11. 1 into 6 into 11 is 66. Remaining 8 in 82. 7 77. And remaining 5 in 59. So 11 is also not possible. So next one is 13. We'll see 13 is possible or not. So 13 into 5 is 65. Remaining is 9. In 92, 13 into 7 is 91. Remaining is 1, 19. So in 19 is not divisible by 13. So 13 is also not possible. So next number is 17. We'll see if 17 will 7429 is divisible by 17 or not. We will just try here. 7429 divided by 17. So 4 into 17 is 68. We will get remainder as 6. In 62, 3 into 17 is 51. Remainder is 1 1. And we'll keep this 9 down. 119. Yes, possible. 7 into 17 is 119. So 17 is a prime factor of 7429. So we can write 17 here. And here 4 3, 7. So which can be the next number? Until 17 we have already tried. So the next number can be 437. Is 437 divisible by 17? 17 into 2 is 34. Remaining, no, 17 is not possible. So which can be the next number? We'll try for 19. 437 divided by 19. So 2 into 19 is 38. Remainder is 5, 57. Yes, possible. 3 into 19 is 57. So we can write 19 and we get 23 here. 23 and 1. So 7429 can be written as 17 into 19 into 23. So this is our solution. Okay. Now let's see question number 2. So what is the question? Find the LCM and HCF of the following pairs of intersection and verify LCM into HCF is equal to product of the two numbers. Okay. So which is the first pair of numbers? That is 26 and 91. Okay. So we'll do that. First one, 26. So how we have to do the prime factorization of 26? 2, 13, 13, 1. So 20, we can write 26 as 2 into 13. How about 91? 91, we have to do the prime factorization. 2 is not possible, 9 plus 1 is 10, 10 is not divisible by 3, so 3 is not possible, 5 is also not possible since it is not ending with 0 or 5. So next one is 7, we will try with 7. 1, 21, 3. Okay. So we can write 91 as 7 into 13. So what is HCF here? The highest common factor in both these, that is 13. 13 is the HCF here. And what is LCM? The highest power of each prime factors in both. So here the highest power of 2 is 1, so we will write 2. The highest power of 7 is also 1 here, so 7. And 13 is there in both, and the highest power is 1, so we will write 13. So that is 182. Okay. So now what we have to do? The question we found out both the HCF and LCM. Now we have to verify that the product of LCM and HCF will be the product of two numbers. So we will do HCF into LCM. 182 into 13. So we will get 2366. Okay. And how about the product of these numbers? Product of two numbers, 26 into 91 is also 2366. Okay. So we have verified that the product of LCM and HCF is the product of two numbers. Okay. Now let's see question number 2, that is 510 and 92. So we have to do the prime factorization of 510 and 92. Two, 2s are 4, remaining 1, 5 2s are 10, remaining 1, in 10, 5, 5, 5 5s are 25, into 1. 5 plus 1 is 6, so we can use 3. 1 into 3 is 3, remain 21, 17. So we can write 510 as 2 raised to 2 into, 2 into 5 into 3 into 17. Okay, and which is our next number? That is 92. 2, 46, again 2, we'll get 23. 23 into 1. So we can write 92 is equal to 2 square into 2 raised to 2, 2 to the power of 2 into 23. Okay. So what is LCM here? No, first we will write HCF. What is HCF here? HCF, the highest common factor in both these. That is 2. 5 is not here, 3 is not here, 17 is not here, 23 is not there. So 2 is the highest common factor. 2. What is LCM? You have to take all the numbers with the least power. Okay. So first is 2 square. We have to take the highest power values of each. So to have 2 to the power 2. Okay. 2 square into 5 into 3 into 17 into 23. It is 4 into 5 into 3 into 17 into 23. The value is 23460. Okay. Now we have to prove that LCM into HCF is equal to product of the two numbers. LCM into HCF is equal to product of two numbers. First number into second number. So we will do that. LCM is 23460. HCF is 2 into 2. We have to check 510 into 92. So the value is 46920, which is same here. For 510 into 92 is 46920. So we have verified. Okay, now we move on to question number 3. That is 336 and 54. So we have to do the prime factorization. 336. We can use 3 first. So 1, 1, 2. Now let's try 2. 5 2s are 10, remaining 1 12, 6. We can use 2 again. 2 into 2 is 4, remaining 1 16. 8 2s are 16. 2, 14. Again we can use 2, it's 7. 7 into 1. So we can write 336 as 1, 2, 3, 4. 2 to the power 4 into 3 into 7. Okay, and how about 54? 2. 2 2s are 4, remaining 1. In 14, 7. 3. 9 3s are 27. 3 again. 3. 3 into 1. So we can write 54 as 2 into 1, 2, 3. 3 raised to 3. Clear? So what is HCF here? HCF is the highest common factor. What are the common factors here? 2 is here, 2 is here. So 2 is a common factor. Into 3 is here, 3 is here. So 3. So the HCF is 6. And what is the LCM here? LCM is equal to the values having the highest powers. So that is, for 2 it is 2 raised to 4, into for 3 it is 3 raised to 3, for 7 it is 7 raised to 1, that is 7, is equal to 16 into 27 into 7. So we get 3024 as a product of these numbers. Now we have to verify that LCM into HCF is equal to product of first number into second number. So 3024 into 6 is equal to 18144, and here 336 into 54 is also equal to 18144, hence verified. Clear? Okay, let's see question number 3. Find the LCM and HCF of the following integers by applying the prime factorization method. Okay, and we'll go to the first question. 12, 15 and 21. We have to do the prime factorization of all these numbers. So 12, 6 2s are 12, 2 again, 3, 3 into 1. So 12 we can write as 2 raised to 2 into 3. Okay, how about 15? 5 3s are 15, 3, 1. So we can write 3 into 5. How about 21? 3 7s are 21. So we can write 3 into 7. So what is HCF here? The highest common factor in all the three, that is 3. HCF is 3. And how about LCM? LCM is the highest power, or the numbers with the highest powers. We have to take all the numbers. So 2 raised to, the highest power of 2 is 2. So 2 square into highest power of 3 in all these is 3. Highest power of 5 in all these values are 5 itself. And same for 7 into 7. Equal to 4 into 3 into 5 into 7. And we will get 420. So this is the HCF and LCM of these two numbers. Okay. Now let's see question number 2. 17, 23 and 29. We will do the prime factorization of these numbers. And it is very clear that 17 is a prime number. So we can write 17 as 17 into 1. 23 is also a prime number. So 23 we can write as 23 into 1. 29 is also a prime number. So it is 29 into 1. So what is the HCF here? The highest common factor in all these values are 1. So HCF is 1. And how about LCM? LCM is 17 into 23 into 29. So we will get 11339. Okay. This is our answer. Now we move on to third question. 8, 9 and 25. Okay. So 8. How we can write 8? 8 is 2 cube. 4, 2, 2. We know that 2 cube is 8. So we can write 2 cube. What about 9? 3 square is 9. What about 25? 5 square is 25. So what is the HCF here? Is there any common factors here? So it's 1. HCF is equal to 1. And what is the LCM here? LCM is equal to 2 cube into 3 square into 5 square, that is 8 into 9 into 25, that is 1800. This is our LCM. Okay. Now let's see question number 4. What is the question? Given that HCF of 306 and 657 is 9, find LCM of 306 and 657. Okay, so the solution, the first number is 306 and the second number is 657, and HCF is also given. We know that LCM into HCF, the product of LCM and HCF is equal to product of two numbers. Product of two numbers. Clear? So that means, what is LCM here? Sorry, we have to find the LCM. So we can write LCM is equal to product of two numbers divided by HCF. That is equal to, what is the product of two numbers? 306 multiplied by 657 divided by, what is HCF here? It's 9. So we can cancel this. 3 9s are 27, remaining is 3, 4 9s are 36. So 34 into 657, we will get 22338. So this is the LCM of these two numbers. LCM of 306 and 657 is equal to 22338. Clear? Okay, now let's see question number 5. What is the question? Check whether 6 to the power n can end with digit 0 for any natural number n. Okay, this is the question. We know that if a number ends with 0, then its prime factors must be a pair of 2 and 5. Right? So we can write, if a number ends with 0, then its prime factors must be a pair of 2 and 5. Right? So 6 to the power n is equal to, what are the prime factors of 6? That is 2 and 3, 2 into 3. But it is not a pair of 2 and 5. So 6 raised to n cannot end with digit 0 for any natural number n. 6 raised to n cannot end with digit 0 for any value of n. What is the reason? Because its prime factors does not contain pair of 2 into 5. Okay, let's see question number 6 now. What is the question? Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. Okay, so what is a composite number? Composite numbers are numbers which are having more than two factors. Okay, so let's take the first number here, that is 7 into 11 into 13 plus 13. So what we can do, we can take 13 as common here since 13 is in both the side of this. Okay, so 13 multiplied by 7 into 11 into 1. Okay, now let's see question number 6. What is the question? Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. So what are composite numbers? Numbers which are having more than two factors are known as composite numbers. So we can take the first number here, 7 into 11 into 13 plus 13. From here we can take 13 as common. So 13 into 7 into 11, this will be plus 1. Okay, that is 13 into 77 plus 1, that is 13 into 78. So 78 have prime factors like 2, 3, 13 and all. Like for example 78, how we can do? 2, 3 2s are 6, remaining 1 18, 9 2s are 18. So we can do it with 3, 13. So we can write 13 into 2 into 3 into 13. Okay, since this number have more than two factors, this number is a composite number. Now let's take example of another number, that is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. What we can do here, we can take 5 as a common factor here. Okay, 5 into 7 into 6 into 4 into 3 into 2 into 1, this will be plus 1. Okay, multiplying this we will get 5 into 1 008 plus 1, that is 5 into 1 009. Since this number is having more than two factors, both these numbers are composite numbers. So we can write both numbers are composite. Both numbers are composite as they have more factors other than 1 and the number. Let's see question number 7. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Devi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Okay. Okay, now let's see how we can solve this problem. What is given in the question? There is a circular path. Okay, circular path around a sports field, and Sonia takes 18 minutes. Sonia takes 18 minutes to drive one round of the field. She takes 18 minutes. While Ravi is faster. Ravi takes only 12 minutes. Ravi takes only 12 minutes to drive one round of the field. Okay, so it's asked at what time, if they start in the same time and the same point somewhere here. Okay, and at what time will they meet again here at this point? Okay, that is the question. So Sonia takes 18 minutes, right? Ravi takes 12 minutes. So they will meet again at the LCM of 12 and 18. Okay. They meet after LCM of 12 and 18 at the starting point. At the starting point. Okay, so what is the LCM of 12? What is LCM of 12 and 18? We will do the prime factorization of 12 and 18. 2, 6, 2, 3, 3 into 1. Okay, so this is 12. And how about 18? 2 into 9, 3 into 3, 3 into 1. So 18 means 2 into 3 square, and 12 means 2 square into 3. So LCM of 18 and 12 is, so what we can write, what is the highest power of 2 here? That is 2 raised to 2. 2 raised to 2 into, what is the highest power of 3 here? That is 2. 3 raised to 2, that is equal to 4 into 9 equal to 36. So Ravi and Sonia will meet again at the starting point after 36 minutes. Okay.